Hello guys, good afternoon. Thank you very much for joining us once again. This session is a GCSE Maths session. It's going to be focused on cubic and reciprocal graphs. It's going to be delivered by the wonderful, the lovely Evelyn. Evelyn is, some of you already know, is currently studying maths at master's level at the University of Birmingham. And I know that she's got amazing things in store for us today. Just a note for those that are joining us for the first time, the session in total will be will be of the duration of 1 hour in length. So we're looking to finish at 3 p.m. Throughout the session, if you have any questions, do feel free to pop them in the chat function or the Q&A section, and both of those are located at the bottom of your screen. And Evelyn or myself will be able to help you out where possible. Great, Evelyn, if you're ready to start, I'll take it over to you.
Perfect, thank you. So today we're going to be going through cubic and reciprocal graphs. So if I just quickly get that up as well now. Hopefully everyone can see it. Yep, perfect. So before we move on to cubic and reciprocal graphs, we're going to do a quick recap on the session we did on Monday on quadratic graphs. So just a quick recap. So a quadratic graph is a graphical representation of a quadratic equation. The important parts of a quadratic graph are the roots, the y-intercept, and the turning point. And to draw a quadratic graph, you should complete the table of values, then plot the correct coordinates on the graph, and then draw a smooth curve that goes through all of the coordinates. So let's go through a quick question on quadratic graphs. So we need to first complete the table of values for y equals x squared minus 5. So they've already done 4 for us, so we just have to do the remaining 3. So let's start with when x is minus 2. So let's, let me use a smaller pen as well. So let's sub in for x is minus 2. So we've got minus 2 squared. Now remember, the reason why I put numbers into brackets is just to make sure that we don't get confused with negative numbers. So we've got minus 2 squared, which is 4, because it's minus 2 multiplied by minus 2. Then minus 5. So 4 minus 5 is minus 1. So minus 1 is our first answer. Then for when x is equal to 2, we do the same thing. We can still put our numbers into brackets. So 2 squared is 4, because it's 2 times 2, and then minus 5 is minus 1 again. So we've got 4 minus 5, we've got minus 1. And then when x is equal to 3, we'll do it in exactly the same way. So we've got 3 times 3, which is 9, minus 5, so we've got 4. So 4 is our answer for this one. So let's write this part down. Sorry, it's moving a bit slow today. So 4 is our answer for this one. So now all we have to do is substitute these into, we just have to draw the coordinates on the graph now. So let's scroll down a little bit and draw the coordinates. So we'll have minus 1, minus 2. So I'll use a little bit smaller pen as well for this. So we've got minus 1, minus 2, which should go, oops. So minus 1, minus 2 goes over here. Then we've got minus 1, minus 4. Sorry, 0. Sorry, let's start again. Getting myself confused. So we've got minus 2, minus 1 as our first coordinate. So minus 2, minus 1 goes over here. Then we have minus 1, minus 4. Then it is 0, minus 5. And then we had 1, minus 4. Then our next one was 2, minus 1. So that would go over here. And then we had 3, 4, which would go over here. And then we had 4, 11, which go up here. And then to get the second mark, all we would have to do is now to draw a smooth curve, which goes through all of the points. So as I said last time as well, it's kind of hard to draw it on the computer, but in your exam, as long as you don't use a ruler and you try and draw your smooth curve all at once, you should get a smooth curve, which would get you 4 marks for your for this question. So hopefully quadratic equations all make sense. So now we can move on to cubic and reciprocal graphs. So today what we'll be doing is we'll look at what do quadratic graphs look like, how to draw what do cubic graphs look like, how to draw cubic graphs, and what do reciprocal graphs look like and how to draw reciprocal graphs. So so first of all, cubic graphs are graphical representations of cubic equations. So a cubic equation is just one which has an x cubed in it. So you could have this equation, y equals x cubed, and it would look like this graph over here. Now this is how positive cubic graphs always look. They always start from the bottom and then go up. Whereas when you look at negative cubic graphs, like the one on the right, they start from the top and they go down. So that's how we can tell a positive cubic from a negative cubic graph. Now, as well as the ones that we've just seen, cubic graphs can look more like this as well. So they don't have to look more like a smooth curve that starts from the bottom and only goes up. It can go up and down and go back up again. So you can have a cubic graph like this with a cubic function like this. One thing to remember is with foundation, with your foundation exam, you won't be asked questions on turning points or anything or roots like that. With cubic graphs, there's only 4 quadratic graphs. Cubic graphs are a little bit easier because all you have to do is plot them or sketch them. You don't necessarily have to do anything more with that, like say working out roots or anything like that. So a quick quiz, out of the following graphs, which one is a cubic graph? So is it A, is it B, is it C, or is it D? So for this particular question, our answer would be B, because it looks just like the cubic graph we saw over here. So it looks just like our x cubed. So this one would be our cubic graph. If you notice, this one, D, is a quadratic graph. So that's what we were looking at on Monday. And the other ones we haven't seen quite yet. So let's continue them. So how to draw a cubic graph. So we do exactly the same steps as we would with quadratic graphs. So we substitute values for x, then we plot the coordinates on the grid, and then we draw a smooth curve that connects all of the coordinates. So let's go through an example. So first of all, we need to complete the table of values. Now here they haven't done any of them for us, so we need to do all of them ourselves. So the equation here is y equals x cubed plus 2x squared minus 1. So let's start substituting in values for x. Let's start with x equals minus 3. So let me use a little bit bigger pen. So we've got y, and then we want to substitute in x is equal to minus 3. So we're going to have minus 3 in brackets, cubed plus 2 minus 3 squared, and then minus 1. So minus 3 cubed is the same as minus 3 times minus 3 times minus 3. So this would give us minus 27. And then we'll have minus 3 squared multiplied by 2. And minus 3 times minus 3 is 9, multiplied by 2 is 18. and then we will take away 1. So when we do minus 27, plus 18 minus 1, what we get is minus 10. So minus 10 is our answer for the first one. Then we have to do the rest as well. So let's do for minus 2. So we'll do minus 2 cubed plus 2 multiplied by, by minus 2 squared, and then minus 1. So minus 2 cubed is minus 8. Then 2 multiplied by minus 2 squared. So minus 2 squared is 4, multiplied by 2 is plus 8. And then we've got minus 1. So our answer for this one would be minus 1. And then if we do exactly the same thing for minus 1. So minus 1 cubed is minus 1. 2 multiplied by minus 1 squared. So minus 1 squared is 1, multiplied by 2 is 2, then minus 1. So this one would give us 0. Now if we did the same thing for 0, you get 0 cubed, plus 0, plus 2 multiplied by 0 squared, minus 1. So 0 cubed is 0, plus 2 multiplied by 0 squared. 0 squared is 0, multiplied by 2 is 0. So this one would be minus 1. And let's do the same thing for when x is 1. So we've got 1 cubed, then plus 2 multiplied by 1 squared, and then minus 1. So 1 cubed is 1. 1 squared is 1, multiplied by 2 is 2, and then minus 1. So this one would give us 2. And then the last one is for when x is equal to 2. This one is 2, so last one is when x equals to 2. So we've got 2 cubed plus 2 multiplied by 2 squared minus 1. So 2 cubed is 8. Then you've got 2 multiplied by 2 squared. So 2 squared is 4, multiplied by 2 is 8, and then minus 1. So 8 plus 8 minus 1 gives us 15. So the last thing to do is now draw, plot these coordinates on the graph and then draw a smooth curve that goes through each of them. So our first coordinate is minus 3, minus 10. So minus 3, minus 10 goes over here. Then we have minus 2, minus 1, and that would go somewhere over here. If I get that a bit more accurate. Yep. And then we have minus 1, 0, which is over here. Then we have 0, minus 1, which would be over here. Then we have 1, 2, and 2, 15, which would be all the way up here. So at the moment, it doesn't look like a graph which we've drawn before. Obviously, we haven't gone through quadratics before, cubics before, sorry. And if we try to follow the graphs that we've seen previously, all we have to do is draw a smooth curve that goes through each of these points. So we can start with the first one and go up, all the way up to the point minus 1, 0. It comes down to this point up here and then goes back up, all the way up to the top. And when we finish, it looks like a cubic graph. So we are correct, and we would get 2 full marks for this. So that is how we draw cubic graphs. Hopefully it makes a lot of sense. It's very similar to quadratic graphs. You plot the coordinates and then you just connect all of your coordinates with a smooth curve. So this then brings us to reciprocal graphs. So a reciprocal graph is a graphical representation of a reciprocal equation. Now, a reciprocal equation is just when your x is on a denominator of a fraction. That's what we mean by a reciprocal equation. Now, in your foundation exam, you are very likely to only really get equations like y equals 1 over x. They don't really get much complicated than that for a foundation exam. Other alternatives could be something like y equals 2 over x, or y equals 50 over x, or even y equals minus 1 over x, which is this one over here. There should be a minus here. But they don't get any more complicated than that. So as long as you know what they look like, then you should be fine for your exam on reciprocal graphs. So a positive one, you have two curves. Now, one thing to always remember with this particular reciprocal graph is that x cannot equal 0. You can't have 0 on your denominator of a fraction. So your lines will never cross this y-axis for 1 over x. So this is the positive reciprocal graph on the left-hand side, and on the right-hand side, you have a negative reciprocal graph. So y equals minus 1 over x. So let's look at this quick quiz. So which of the following of these graphs are reciprocal graphs? So is it A, is it B, is it C, or is it D? So for this particular question, our answer would be A. So A is our reciprocal graph because it looks just like the ones that we've just seen. B would be a quadratic graph and C would be a cubic graph. So another way how, if you are asked questions like this quiz, a good way to answer them is if you're not too sure, there's probably other graphs which you do know and you can rule them out. So let's go on to drawing reciprocal graphs. So we're going to do it exactly like how we were doing cubic graphs and quadratic graphs on Monday. So we're just going to substitute values, plot the coordinates and draw a smooth curve. So with reciprocal graphs, they will come up in a calculator paper because you are allowed to use a calculator to work out these values, and that's exactly how we're going to do it for for this question, because they won't expect you to always work it out. They will expect it for quadratic and cubics, but not necessarily reciprocal ones. So the first thing that we need to do is to complete the table of values. So for x equals 0.25, so we need to do 2 divided by 0.25. So using a calculator, this will give you 8. So y equals 8 for x equals 0.25. And the next one is for x equals 0.4. So you need to do 2 divided by 0.4, which would give you 5. And then for x equals 0.5, you need to do 2 divided by 0.5, which would give you 4. Then you need to do the same thing for when x is equal to 0.8. So you would get 2.5. Then you do the same thing for 2 divided by 1, which would just be 2. And then 2 divided by 2, which would give you 1. 2 divided by 4, which would give you 0.5. And then 2 divided by 5, which would give you 0.4. So now we've worked out all of our y values for our x values. So all we need to do now is plot our coordinates. So for x is equals 0.25. For this one, I'm going to need to zoom in a little bit as well. So x equals 0.25, y equals 8. So let's zoom in. So 0.25 would be this one over here. So we want to go up to 8. 0.25 all the way up to 8. So our coordinate would be around here. Yeah. And then for 0.4, y is 5. So for 0.4, let's go up to 5. Then you have 0.5 going to 4. And then you have 0.8, which is at 2.5. And you have 1, 2, 2, 1, 4, 0.5, and 5, 0.4. But for this question, they haven't left space for the 0.4 point, but it would be somewhere over here if we were to continue it, yeah? So we've plotted the coordinates. The only thing left to do now is to draw a smooth curve that goes through all of the points. So we start from the first one and we try to draw as smooth a curve as possible that goes through each of these points. Like this. Now, one thing to bear in mind is that with your reciprocal graphs, one thing to remember is that it depends on your x values, whether they're positive or negative. Okay, so if we go back to this part, for your x values which are negative, as long as you have a positive reciprocal equation, so y equals 1 over x, and for your negative values of x, you have this curve down here. Now, all of your values which are greater than 0, your x values which are greater than 0, you have a graph which looks like this. So in this particular equation that we were doing, we only used positive x values. So we only used x values 0.25, 0.4, 0.5 and whatnot. We don't have any negative values, so we're not going to get a graph or any curve down here. We're only going to get one up here. So that's one thing to remember. So only because you're not getting two separate lines doesn't necessarily mean that your answer is wrong. So if we continue, when we are using and going through cubic and reciprocal graphs in your exam, also part of your specification, you're expected to know how to sketch cubic and reciprocal graphs. Now, because cubic and reciprocal graphs are a little bit more challenging than quadratic graphs, you only need to be able to sketch simple cubic graphs and sketch only one reciprocal graph. And the only one reciprocal graph you're expected to know how to sketch is 1 over x, which is the one at the bottom of the screen. Now, when I say simple cubic graphs, we're sketching those, it only means the normal cubic graph, like say y equals x cubed, but being multiplied by some number. So it's still going to be the same shape. It will either be thinner or a little bit wider. So if the number that you're multiplying your x cubed with, like say 5x, your graph will be a little bit thinner. If it's smaller, like say 0.5, it will be a little bit wider. So those are the only sorts of graphs which you're expected to know how to sketch in terms of cubic and reciprocal graphs. So that makes your life a little bit easier. You don't need to be able to sketch all different types of cubic and reciprocal graphs. Now, last time on Monday, we went through a couple of the common mistakes that people go through or that people make during their exam. One thing is the curve doesn't go through all of the points. You have to make sure that your curve goes through all of your points and that your curve is very smooth. Now, even though everyone finds it quite difficult to draw a very, very smooth curve, they're not expecting you to draw a perfect curve. They just want to make sure that you're not using a ruler. So do not ever use a ruler when sketching curves. Wobbly curves, it's not necessary, like say when I was drawing them, you are sort of getting curves which do wobble a little bit. That's okay, but what they mean is nothing like that, where it's very obvious that you're not trying to keep it as smooth as possible. As long as you're attempting to, you will get the mark. Make sure you plot all your points correctly. If one looks like an anomaly, that means you've got it wrong. So you have to recalculate and make sure that you do them all correctly, and make sure you connect, make sure you don't connect any of your lines, any of your curves with a straight line. Otherwise you will get the question wrong. Now there is a difference between sketching and plotting. So make sure that you understand the difference between the two. So sketching, you only need your axes, and you only need to label maybe your y-intercept. But with cubic and reciprocal graphs, as I was showing you before on this part, when you're sketching a reciprocal graph, make sure that your curves do not touch the axis. Otherwise you will get it wrong. You have to draw it just like the graph at the bottom of the page. Make sure that they do not touch the axis. Otherwise you will get the mark. You will not get that mark. The cubic graphs, make sure that it goes through 0. As long as it only goes through 0, you will get your mark, as long as it looks just like these graphs here. So take a good look at these ones, make sure you understand it, and then we're going to move on to recognizing them. So let's move on to recognizing them. So the different types of graphs which you're expected to know and expected to recognize and interpret are linear graphs. So those are just straight line graphs, ones which we've all seen before. Quadratic graphs, which we saw on Monday, so U-shaped curves, whether it's a normal U-shape or an upside down U-shape. Simple cubic graphs, which is what we were going through today, or the single reciprocal graph, y equals 1 over x. So those are the ones that you're expected to recognize and interpret. So a quick recap on what all these graphs look like. So linear graphs, again, are straight lines. So those are quite easy to remember, because those ones are the ones which we use very often. Quadratic graphs are U-shapes, and then you have your cubic graphs. So they could either look like the one on the left, the one in the middle, or the one on the right. Make sure that you understand the difference between a positive cubic graph and a negative cubic graph. So they're sort of like reflections of each other, but positive ones start from the bottom and work its way up, whereas negative ones start from the top and work its way down. So remember that one. And then also with reciprocal graphs, you have to remember this particular one. So now that we've sort of done a quick recap of all of these examples, and what we are going to do now is do a quick few questions on recognizing them and matching graphs with the equations. So which of the following could be the graph of y equals x squared minus 7x plus 10? So first of all, this equation is a quadratic equation. So we know that we're looking for a quadratic graph. So this one is not a quadratic graph, it's a cubic graph. And this one is not a quadratic graph either, because it's a straight line, so it's a linear graph. So it could either be C or D. Now going back to what we did on Monday, we know that this is a positive cubic graph because our it's a positive quadratic graph because our x squared is positive. So we know that it should be a U shape, not an upside down U shape. So our answer would be D. So as I was saying before, the best way to answer these questions is by a process of elimination. So just eliminate the ones which you know are definitely not that one, and then you can decide which one is which at the end once you've eliminated the ones which are obvious. So if we do a similar question, we now have to match the graphs with the equation. So the easiest one I would say is our linear graph. We know what linear graphs look like. We know what linear equations look like. So the linear graph B is going to match to our first equation, y equals 2x, because it's a linear equation. So B matches with 1. Now, the other one, which we are very familiar with now, is either a cubic graph or a quadratic graph. So our cubic graph is D, because that's what we were doing today. Now, a cubic equation is when you have an x cubed, and the only one down here which has an x cubed is equation 3. So D would be a cubic graph. Now, between the last two, we know that C is a reciprocal graph. Now, a reciprocal equation is when you have an x on the denominator of a fraction. So you know that equation 4 is C, and then the last one is a quadratic graph. So the last one would match with A. And we know that we know that an equation with an x squared be a quadratic equation. So hopefully that makes a lot of sense now, or even a little bit more sense than before. I think that we have enough time to go through a few more examples of questions. So let's do this question then. So we've got a cubic equation, y equals x cubed minus 2x plus 3. So what we have to do now is complete the table of values, and then once we've done that, we can draw the graph. So let's start with x equals minus 2. So let's substitute in x equals minus 2. Got minus 2 cubed minus 2 multiplied by minus 2 plus 3. So always remember to put your numbers in brackets. Now minus 2 cubed is minus 2 multiplied by minus 2 times minus 2, which would give us minus 8. Then we've got minus 2 multiplied by minus 2, which gives us plus 4. And then we can add our 3. So we've got minus 8 plus 4 plus 3 gives us minus 1. So minus 1 is our first answer. Then we have minus 1 cubed minus 2 multiplied by minus 1 plus 3. So we're just substituting in for x equals minus 1. So minus 1 cubed is minus 1. Then you have minus 2 multiplied by minus 1, which gives us plus 2, and then plus 3. So this one, the answer to minus 1 plus 2 plus 3 is 4. So 4 is our next one. So we can do the same thing for 0 cubed minus 2 multiplied by 0 plus 3. So 0 cubed is just 0, then minus 2 multiplied by 0 is 0, and then add 3. So 3 would be our answer for this one. And then do exactly the same thing for x equals 1. So 1 cubed is 1, then minus 1 multiplied by 1 is minus 2, and then plus 3. So 1 minus 2 plus 3 is 2. 2 would be our answer here. And then we can do the same thing for our last x value, which is 2. So we've got 2 cubed, which is 8. Then we've got minus 2 multiplied by 2, which is minus 4, and then plus 3. So 8 minus 4 plus 3 equals 7. So 7 is our final answer for our table of values. So the next point is to now plot our coordinates and draw a smooth curve that goes through each of these coordinates to finish off our graph. So our first coordinate is at minus 2, minus 1. Our next one is minus 1, 4. Then we have 0, 3. Then we have 1, 2. And then it's 2, 7. So if we draw a smooth curve that goes through each of these coordinates, you should get something that looks like this. Oops. Let's try that again. There we go. So yeah. So again, so like what I was saying on Monday, if you do draw a curve and it's not quite going through all the points, what you can do is you could rub out that little part and then try and make sure that it goes through all of the points. It's okay as long as you try and keep your line as smooth as possible and make sure that it doesn't look like you've got multiple lines going through points, as long as it's just one smooth curve that goes through them. So the best thing to do is always use pencil, never use a ruler, and it's okay to make sure that it's okay to rub it out as long as you fill it in properly and make it look as smooth as possible. So let's try another question, but now in regards to a reciprocal graph. So this is a past paper question from June 2017, paper 3. I think this is the Edexcel paper that this one is from. And as I said before, anytime they ask you to draw to sketch or to plot a reciprocal graph, it's not going to be something very complicated. So this one is just 6 over x. So for each x value, what we're going to do is we're going to substitute x, our x's. So we'll do 6 divided by it, and then you can calculate it. And as I said before, these come up in calculator papers. So this one was in paper 3. So let's start with x equals 0.5. So when x is 0.5, you can do 6 divided by 0.5, which would give you 12. So 12 would be your first one. So you can use a calculator, or you could simplify the fraction, but I would say if you're allowed a calculator, the best thing to use is a calculator. The next one is 6 over 1.5. So you can do 6 divided by 1.5 on the calculator, you will get 4. Then the next one is when x is 3. So this one would be 6 divided by 3, which is 2. So y equals 6 over 3, which gives you 2. Then the next one is when x is 5. So you've got 6 divided by 5. When you do 6 divided by 5, you get 1.2. And then the last one is 6 divided by 6, which is 1. So now you have all of your coordinates. The second part, part B, is now asking us to draw it. So we just need to plot our coordinates and then draw a smooth curve that goes through each of them. So the first one is 0.512, which is over here. Then you have 1, 6. Then you have 1.54. Then you have 2, 3. 3, 2. 4, 1.5. 5, 1.2, which would go over here, and 6, 1. So we can see that it's going to look like a smooth curve. So we can go ahead and start drawing our smooth curve that goes through all of the points. And you would get 2 marks for this, or full marks for this question, if you've got all your values in your table correct, and you've plotted all your coordinates correctly, and you've drawn a smooth curve that goes through each of these points. So we probably have time for one more example, and then we will open up to questions. So let's do this one then. So we've got x cubed minus 3x squared plus 12. So let's start with x equals -2. Got y. Then substitute in for x is -2 cubed minus 3 minus 2 squared plus 12. So this one, we've got -2 cubed, which is -8. We've got -3 multiplied by -2 squared. -2 squared is 4, multiplied by -3 is -12. And then plus 12. So our answer for this one would be -8. Got -8 here, and then we can do the next one, which is for x is equal to 0. We've got 0 cubed minus 3, 0 squared plus 12. So 0 cubed is just 0, minus 3 multiplied by 0 squared is going to be 0, and then we add our 12. Got 12 here. Then we can do the same thing for when x is 1. Y, and then 1 in brackets, squared plus 12. So 1 cubed is 1, minus 3 multiplied by 1 squared is -3, and then plus 12. So 1 minus 3 plus 12 is 10. And then you've got for when x is equal to 2, let's do this one. So we've got 2 cubed, which is 8. Then you've got -3 multiplied by 2 squared. So 2 squared is 4, multiplied by -3 is -12, and then plus 12. So for this one, you will get an answer of 8. And then for x equals 3, our last one. So we will have 3 cubed minus 3 squared plus 12. So 3 cubed is 27, so it's 3 times 3 times 3. We've got -3 multiplied by 3 squared, so 3 squared is 9, multiplied by -3 is -27, and then plus 12. So our answer for this one would be 12. Okay, so we have filled out our table of values. The last thing to do is to plot our coordinates and draw a smooth curve. So let's start with our first coordinate. So we've got -2 minus 8. So -2 minus 8 would go over, so we've got -9 minus 8 would go about here. Then you have -1 minus, -1, 8. So -1, 8 would go over here. Oops. And then you have 0, 12, which would go over here. Then you have 1, 10, which is over here. 2, 8, which is over here. And 3, 12, which is back over here. So we now just have to draw a smooth curve that goes through all of these points. So you should get something that looks very similar to this. So hopefully that clears up cubic and reciprocal graphs for you. So let's look at some questions then. Can't seem to access the questions.
You can't see the Q&A?
No.
That's fine. we've got a question here asking, is there a graph, asking for linear graphs, when you join the plots, do you draw a straight line or a smooth curved line?
Okay. So for linear graphs, it's always a straight line. So always use a ruler for linear graphs. For any other graph, such as a cubic or reciprocal or a quadratic, it's always a smooth curve.
Amazing. We've got a way more general question here asking how you find y, but I think you may have answered it already.
Okay. So when we're working out what y is, what we should do every time is for values of x, you substitute your x value. So like say for here, our first one that we did was x equals minus 2, sorry. So all I've done is I've replaced all of my x's in the equation with a minus 2. So do minus 2 cubed, then minus 3 multiplied by minus 2 squared plus 12. And then you calculate it. And once you've calculated the equation, you get what y is equal to. Hopefully that answers your question.
Great, we've got a few more questions here now. Guys, do remember that you can also use the chat function to drop in questions. We've got a question asking, do you start the line from the edge of the graph or from the first point?
I would say always start from the first point. So because we want to get a smooth curve, it's best to start from the first point and don't take your pencil off the paper until you've gone through all of the points up until the last one. That way you're able to get a smooth curve all in one go, rather than getting loads of different lines. Because if you do have loads of different lines on your graph, they won't give you the mark. They'll only give you one if you have one smooth curve.
Great. We've also got another question asking, if one makes a mistake with one plot, will it affect the whole question you answer and impact marks?
Okay. So in your exam, the way how they'll structure it is usually just like this. So you complete the table of values and then you sketch the curve. Now, if you get one of your points wrong, one of your y values, let's say for the first one you got a minus 7 instead of minus 8, sometimes depending on the exam, you can get follow-through marks. If you do plot minus 7, minus 2, minus 7 on your graph and then draw a smooth curve through there, they might still give you the mark because you've drawn a smooth curve. However, a lot of the time, especially with reciprocal graphs and quadratic graphs, it's quite easy to spot when you've made a mistake. Let's say you've got, instead of minus 8, you have something like minus 12 and it's all, or minus 15, it's all the way down here. It might not look right. So if it doesn't look right, just recheck all of your answers, because you probably will recognize when you haven't done the right equation or when you haven't gotten the right answer for one of your values. So hopefully that answers that one as well.
Amazing. We haven't got any more math specific questions. Are we able to maybe go through some more sample questions?
Yeah, definitely. So let's go through. I've got another one here for reciprocal graphs. So this one, sorry, this one is particularly for your negative values for x. So remember last time, or not last time, but a little bit earlier, I was talking about whether your x values are negatives or whether your x values are positive. So this one, we are going to get a graph which looks similar to the ones that we've been doing, but slightly different. So again, we can use our calculator for this. So our first one will be, what is y when x is minus 10? So we're going to do 4 divided by minus 10, which will give you minus 0.4. And then you can do, then the next one is 4 divided by minus 8, which is minus 0.5. Then you'll have 4 divided by minus 5, which is minus 0.8. And then you have 4 divided by minus 4, which is minus 1. Then you have 4 divided by minus 2, which is minus 2. And 4 divided by minus 1, which is minus 4. And then 4 divided by minus 0.5, which is minus 8. 4 divided by minus 0.4, which will give you minus 10. And then 4 divided by minus 0.2, which will give you minus 20. Now again, on this particular graph, the grid that they've given you isn't as big to allow you to do minus 0.2, minus 20. So we're not going to be able to plot that point, but we will be able to plot the other ones. In your exam, they will always give you graphs which are big enough to allow you to plot all the points, by the way. This is just an example question. So let's go ahead and plot these points then. So we've got minus 10, minus 0.4. So minus 10 minus 0.4 will go over, it will be around here. Yep, and then you'll have minus 8 minus 0.5, which will be around here. And then you'll have minus 5 minus 0.8, which will be a little bit lower over here. Then you have minus 4 minus 1, which will be here. Minus 2 minus 2. So minus 2 is over, yep, here. So minus 2 is here. Then you have minus 1 minus 4. So it's now going to go around here. And you can have minus 0.5 minus 8. So that would be around here. And then minus 0.4 minus 10. So it will just be a little bit closer to the y-axis. So the last thing that we can do is to draw a smooth curve that goes through each of these points. So let's try and draw a smooth curve that goes through all of them. And as I said, it's kind of hard for me to do it on a computer, but something roughly that looks like that, as smooth as you can, you'll get the marks for it. So as I said before, it will look very similar to the equation that we did previously, but because this is all negative numbers, it will be on the bottom left part of your grid, not the top right, if that makes sense. And because it is your negative values of x that we're working with this time and not positive values of x. So this could be a potential question that comes up in an exam as well. And to finish off, because we have a few more minutes left, what we can do is maybe look at some more of the recognizing questions, because those are quite popular, and that's quite likely to come up in your exam as well. So we want to match the graphs with the equations. So first of all, we can spot a linear graph. So we've got a straight line over here. So we know what a straight line graph, what a linear equation looks like. So it's just when we have an x, a y, and a number. So it will be this one over here. So this is our linear equation matched with our linear graph. Now, the other one that is also quite that is also easier to spot as well is the reciprocal graph, because it's the only one which really has two separate curves. Now we know that reciprocal graphs are when x is on the denominator. So the only equation that has this is equation 3. So C matches with equation 3. Now A and B are both quadratic graphs, sorry. But one is a U-shape, the other one is an upside down U-shape. Now the only thing that we have to remember here is for positive quadratic graphs and negative quadratic graphs. So a positive quadratic graph will have a normal U-shaped curve, just like B. Now that means that this one is positive quadratic graph, so we need to look for a positive quadratic equation. So between the last two equations that we have, equation 2 and equation 4, we want to look for the one that has a positive x squared value. So all the other numbers in the equation doesn't really matter. It's only the x squared, whether that is positive or negative. So the only one here that is positive x squared is equation 2. So it's B. B is matched with equation 2. Now A is an upside down U shape, so it is a negative quadratic. So we're looking for a negative x squared, which is over here. We've got a minus x squared. So this one would be matched with A. And that is it. I mean, would you like another question? Do you have time for another question, maybe? Can look at let's look at this one then. This one won't take too long to do. So this one is another question that we have. So again, we can spot the linear graph, which is C, because that's a straight line. We know what a linear equation looks like. It would be equation 1, so we can write C with equation 1. Now the other one, which is quite easy to spot, is a quadratic graph, because it's a U shape. The only quadratic equation here, so the only one with only an x squared would be equation 2. And then we now have to figure out between A and B which one is which. Is it equation 3 or is it equation 4? So again, this one, we have both a positive cubic and a negative cubic. So a positive cubic graph is one which starts from the bottom and works its way up. Both of these are actually positive cubics. Now, one thing which we have to remember is, what does a normal cubic graph look like? A normal cubic graph goes through the center 0 and no other points on the axis. So this is our normal cubic equation. Now, our normal cubic equation is equation 4. So this is the one which we have to remember how to sketch. That's the one that we looked at earlier. And that leaves the last one. So we can only match the last equation with the last graph. So that means that equation 3 is graph A. So hopefully that clears up cubic and reciprocal graphs.
Amazing. Thank you very much, Evelyn, for such a great lesson. For those asking about bits and pieces of the lesson they've missed so far, do remember that all of the sessions are recorded and uploaded onto our YouTube channel. So both of these sessions should be up there by tomorrow latest. So you can go on there to rewatch any bits that you may have missed. Again, those asking about different subjects and different levels, key stages that we're going to deliver sessions on, make sure that you are signed up to our weekly updates so you don't miss any updates concerning timetables and subjects that we're delivering. Thank you all for joining us. Have a lovely afternoon. Bye.
Bye.